Welcome to my YouTube channel, which is for first video for Tolerant Computing playlist. Bismillahirrahmanirrahim. Welcome to the introduction to fault-tolerant computing, which is presented by Zephyr Shepard. My YouTube channel is Next Generation CE. Now today, first of all, I will discuss about what is the introduction to fault-tolerant computing. It is the first of all we will tell you about the fault-tolerant computing. It is the past 50 years have seen computers from being expensive computation just used by government and big corporation to becoming an everyday commodity, pretty better in practically every aspect of us. And this first point is it is characteristic that it is first used in the government and big corporations companies. Every day to competitive and deeply impacted systems, which you call, and in practically every aspects of life. I don't know, not only our computers visible in desktops, tablets, and PTS. PTS means programmable desktop assist. But it's also a common place that the invisible everywhere vital components across some appliances, medical areas, the steel plants and power generation distribution. And now it is not only computers visible for talent computing is it is first everywhere in desktops, laptops, and PDS. And now it is advanced into various user applications users such as components of cars. You have many things as the TV of the cars, home appliances such as air fryer, medical units such as the X-rays and many aircraft, industry plants power larger in scales of the semiconductor and power generation and distribution. Not just the economy. Computer systems underpin most of the world's financial system given current transaction volumes. Trading in the stock, bonds, and currency markets would be unthinkable without. In this, it will tell about the stock market exchange business and for the stock market exchange is telling about this. And after that is increased willingness as a society. Now is to place computers in life critical and world critical applications is largely driven by the increasing possibility that computers offers. Now in this, so it is the willingness of the increasing of the computers now. Applications life critical and well critical for the business many billionaires billionaires use for the business for the. And now it is dependent more at more computers to carry out all of these further actions. Simplicity, explicitity, gambling of lives. In gambling, it is not the casino, drug, illegal gambling. In the gambling of lives is to improve our lives. So that it is into the scaling of the computer and the properties and computers doing their jobs properly. Now we'll tell you about the exact meaning what it is the gambling of our lives. The gambling means in the fault-tolerant in computing is refers to a risky design data of variables the operators have the chance of failure in certain non-critical scenarios to gain significant improvements in performance or reduce cost. And now here comes the computers are the plus, so they're quite likely the most complex system even ever created by humans. It is telling about that the hardware plus software are the more complex system that created by human beings. If the it's just like AI is also AI, artificial intelligence AI tools are also done by the human beings. And now the complexity of the computer is still increasing as designing attempts to exploit the higher transistors density that new generation of technology make available to them. With this term, it is about the computer to complexity. It's just the most that the number of transistors is increasing year by year. Here it is the same scenario is talking about the new generation of dynamic. Now, computer software is far more complex still, and with that complexity comes to an increased for velocity difference. It is telling about this computer software will be very free to increase popularity. After that, it is probably fair to say that there is not a single large piece of software hardware today that is free bugs. If you do programming, just like I give you example, C++, Python, Java, whatever programming language, if you use doing code just like I would say, I would like to say H calculator by doing C++. You have to do first you have to do debug. What is debug? To debug is to do detect the bugs and eliminate it and give the output. Same is the it is telling about the fault algorithm. Now after that, even the space shelter software that was developed and tested using some of the best and most advanced techniques known to engineering systems to have run with bugs. That had the potential to cause catastrophe. Now if you see the NASA using software, same thing as fault-tolerant computer thing. With the software that was developed and tested. Here is telling about the software testing, which is C language or C Java. The potential cost of a means the certain widespread software failures for system that cause chaos or damage or disruption. The computer scientist engineers that is talking about me, I am also computer engineer. I've responded to the challenge of design complex system with a variety of tools and techniques to reduce the force in the system. And this time is to talk about the chips design. PCB design we have made, now the ECDA, Geiger, LTM design, and many other PCB design bodies. Now this is used. And is used that first of all we delete the data sheets. The data sheet will take the pins diagram and configuration. Now, however, that is not enough. We need to build systems that acknowledge the existence of faults as a fact of life and incorporate techniques to tolerate these faults while still delivering an acceptable level of service. Now, that is not enough. We need to build systems that acknowledge the existence of faults. We have to improve the fault, to remove the faults and improve our system day by day, and we have to techniques to tolerate the faults. Still delivering a surface level service. We have to improve hardware device to improve motherboard and computer devices. The resulting field of fault tolerance is the subject of these books, and I will tell you day by in the next section. Now I will tell you about what is the fault tolerant computing. As I'm sorry I didn't mention it before. The fault-tolerant computer is refers to the design of computer system that can continue operating correct and without interruption despite the failure of one or more of its components. It is called the fault-tolerant computing. The artistic classification comes. In arbitrary language, the terms fault, failure, they are used in integers. It means we use fault, failure, and error are used interchangeable daily language. Now, in the engineering term, it is used to parallel solve a different distinctive meanings. A fault or failure can be a hardware defect or a software mistake, just like bug. In constant analysis, a manifestation of the fault failure bug. In that way, if we do solidity kind, if we do mistakenly not to solidity, it will collapse the many mistakes and will be destroy all structures. In software, if you're doing a large scale of projects doing computing programming, it will cause us and will be lots of soft loss. And now we will construction. Consider at the circuit, you have the digital logic circuit, full at the 2-bit at the 4-bit at the subtract at the 2-bit subtract at the 4-bit subtract. But that will I stuck at one. I will tell you about the details while we were talking about digital logic design. It is I will give you an overview. It always caches the value of one independently. Output is always independent, and the inputs are dependent on the circuit working. This is a fault, but not yet an error. It means this is a fault, but not an error. It means as simple we do while coding and while doing designing a circuit. It's called that. The fault is not fault means the failure. Now the fault causes an array that is used and the result on that is supposed to have been one. That is, it is the Pani language, Pani teacher, zero. A similar distinction exists between programming mistake and execution errors, as I mentioned before. Now consider another example I will tell you. Consider, for example, a subroutine that is supposed to complete syntax according to a programming mistake and calculates that absolute value of sin x instead. And telling out this sine wave according to a programming mistake. Not just continuing. This mistake will result in an execution error only if the arithmetic subroutine is used and the correct result. It is talking about the software. Yeah, while we're doing programming. Both false and S can be separated to the system. In here, it is telling about hardware and software, both the combination. And now here is the example of the hardware. If a chip shows short power to ground, it may cause nearby chips to fail as well. And this I will say if you be doing circuit design, if you don't add the current wire and you pass the current up to the voltage, it will be short circuit and the circuit will be destroyed because current wire is not given. And now S can be separated because the output of one is used as input by other units. As a artisan, if you're making a circuit, doing practical in ETC, I will tell you about it is electronic devices. ETC, I will tell you about this overview. Now, after that, the return to our previous examples, the enormous results of it that the faulty atom or the syntax. Subroutine can be found in the vertical condition thus together. In the next chapter, upcoming chapters, I will tell you details. It is just introduction. That now everything has the limit. The training at this every limit is about the storage capacity, memory capacities, cost, efficiency, expense. Each everything has a limit. The limit such containing design and containment zones into systems. These are the pages that reduce the chance that the fault or error in one zone will propagate. The next chapter, it will be a lots of calculations I will tell you in the next week, next after 2 weeks. For example, here comes the next example. For example, a fault containment zone can be get by ensuring that the maximum possible voltage, especially if you're making a circuit designing a pattern, practically you know the maximum voltage. If you're doing excavate more than possible voltage value, it will cause the damage and to short circuit, the circuit will be destroyed. And it will cause fire risk, fire explosion. It will cause hazard shifting at the moment I will tell you when we will when I will be able to make the next lectures. But here it is to telling about the fault-tolerant computing. In other decided test electrically trusted ones of it is telling about the electrician, electrical engineer, and computer engineer. This computer engineering is the combination of computer science and plus electrical engineering. At the now, it is the block diagram. At the now, it is the and now it is. Let me tell you about the air containment zone can be guided as well as in some detail later on. Fascinating in this program, so working and it is telling about the computer architecture. We will discuss in detail about what is air containment zone. No, hardware faults can be classified according to several aspects, just like environment, workplace, while main thing is if you're doing hardware testing, please don't visit in the AC because the temperature difference it will crash your hardware. You can always use in the do not do not switch on the fans and turn on the AC. You just heat the environment. The cutting into hardware force can be classified into permanent, transient, or intermittent. And in project system, I will tell you about it there. It's all about talking about the embedded system. All the microcontrollers, I will tell you each section's details one by one. I will tell you. Okay. A permanent fault is just that it reflects that permanent concurrent of commission of a component. It is a permanent fault. It's just that it reflects. It tells you about the exponent about the commission of the components. Not example of a permanent fault link of permanent light bulb that is at high voltage stages. And not consistent for system one or that because a component that malfunction for some time it goes away after that and after the functionality of the component is fully restored. Studying about the final letter to how do we get overcome transist fault. And now is the example of the transisted fault. Think of a random noise interface during a telephone conversation. This is telling out the single signals and system subject goes out there laughing. At the other example is a memory cell with connects that change suppressing due to some electromagnetic is telling about sorry, telling about the ETC signal system. Now this cell is itself is undamaged. It is just that design that contains drawing for the time and overwriting the memory set will make the further. It is telling about the Verilog, digital system design, signal system, computer architecture design, and many more Verilog designing. It's telling about. And now, the last slide of the fault classification. An intermediate fault never quite goes away, and it oscillates between being consistent and active. Now, first of all, we want to understand what is Q secant. Now, Q secant state is a stable. First, the Q secant is a state. It's a stability of state in which a distributed system, a specific part of it, Just like the microcontroller, first example, microcontroller ESP sensors specific part. If you make a hardware system, it's called percent because we're telling out the specific part working. Okay, good. Okay? And the first second component is about the 24 in the specific part, the component functions normally. When the for is active, the component, the malfunction. When the for is the active, the component malfunctions. That example comes. And an example for an intermittent fault is a loose electrical connection. As already done when you connecting wires with the resistors wires, when you make the temperature voltage, it becomes malfunction if you don't to adjust correctly. Now, for that causes a unit to code that is called pin gain. First of all, I will tell you what is pin gain. Pin gain refers to emails of software. First, that harmless software intentionally posting no significant that will malicious. Such faults are easy to deal with as a far more insidious than the force that cause unit to produce this looking but indirect output that make a common act malicious and send different related outputs to different lists. Please talking about the network security and cryptography. I will tell you about it in details. We're just talking about the wires. Now think of now last point of all classification of this slide of the last slide of the fault class. Think of at least sensing. In the neighborhood was a thousand to 1 unit and data these are the managers of percentile force. I will tell you what is the pulse. You know the percentile empire comes from this word, percentile force. It's the most difficult surveyor type of all the distributed computer system. It is very famous to explain the challenges of digital conscious decentralized systems where somebody's will be data. The types of redundancy. Now, all of the followers are exercise exploiting managing redundancy. Now, first of all, redundancy is the property of having more of a resource than in minimal necessity to do the job of a job. Latency, I will tell you the computer architecture transposes the latency with the types at the details one by one. Next failure happens, latency is exploited to mask or otherwise work around. This failure does maintain the desired level of functionality. It turns about a failure happens. Everything if you're doing working failures happens. Maintaining desired level of functionality is to overcome the fault. Now there are the four forms of redundancy: hardware, software, information. The first is hardware fault. You should test with by using hardware information or time redundancy, where software faults are protected against by software redundancy. So it is the already mentioned hardware redundancy is providing an incorporating extra hardware into the design to interact overlap the effects of failed component. Next sample goes, instead of having single processor, we can use two or three processors each perform the same function. Just like many motherboard microcontroller, they have many processors and they perform same function. Now, by having two processors, we can detect the failure of a single processor by having three. We can use the majority output to override the long output of a single faulty process. If the one processor having fault, majority of output to override the long output of one single faulty process. Now, this is an example of the static hardware redundancy, the main object of which is the immediate mastery of a film. Now, the first form of hardware redundancy is dynamic redundancy, whereas, oh, sorry, where spare components are activated upon the failure of the active component. Note that a combination of the static and dynamic combination is the static dynamic techniques. Everything has their own techniques. So also possible relating to hybrid hardware returns. Hardware returns can thus range from simple duplication to complex instructions. This which is spare use when active ones become faulty, and which is not active it does not become faulty. These forms of hardware latency incur high overheads and they use for normally reserved for critical systems where such overheads can be justified. And practically, substantial amounts of redundancy are required to protect against malicious faults. The best known form of information redundancy is error detection correction code. I will tell you about in the computer architecture organization. Okay. Next up is can computer architecture organizations. If you have studied computer architecture organization, then this course you can easily understand. Next step is called check bits are added to the original bits so that an error in the database can detect it even corrected. Not the resultant can detect error correcting codes are largely used today in memory use and memory stores devices to protect against weekend failures. Note that this is codes like any other form of information redundancy, external hardware to process Ethernet data check pins. Check pins. Error detecting and error correcting codes are assigned to protect data communicated our noisy channels which are channels that are subjected to many transist failures. Now, these channels can be identity communication links only separated process. Example the internet or among locally connected processors that form a local network. Now, if the code if the code is used for the data alone, these channels can be the communication links among widely separated processor. Example, the internet or among locally connected processors from a local network. If the code used for data communication will tell you the computer communication network, CCN, thoroughly. The scheme for the one detected the first head of occurred from not correcting them. Again, need down smart as necessary, thus the breakdown needed then C. Now, in addition to in addition to transist data communication faces the noise, local and networks may experience persisting failures. These failures when we disconnect not the more existing communication, but the longer communication therapy between certain nodes. The network allows data between certain node pairs. Even the complete disconnection of certain nodes from the rest of the network. Internet communication links, that is hardware redundancy can be alleviated most of these problems. Now the computing nodes can also explore time redundancy to re-execution of the same program on the same hardware. As before, time redundancy is effectively against the assist force because the majority of hardware faults that persist, it's unlikely that the separate executions will experience the suffer. Time redundancy can thus be used to detect transist faults in situations in which such faults may thus go undetected. No, TM redundancy can also be used when other means for detecting errors are in place and the system is capable of recalling the system for the facts it was eliminating computation. Time telling what it times can also be used when other means detecting telling what the capacity, time complexity. Compared with the other forms, redundancy has much lower hardware and software but increase high performance penalty. The software redundancy is used mainly against software fields, just as coding. It is a reasonable guess that every large piece of software that is heavy will produce as content faults. No, dealing with such faults can be expensive. One way is for the independently produce two or more versions of faulted software preferably by distros, teams of soft programs in the hopes that are in different which will not fit in the same model. The second versions can be based on simpler, less accurate algorithms and consequently less accurate faults can to be used only upon the failure to of the primary software to produce acceptable results. Just as for hardware, redundancy multiple versions for the program can be executed they concurrently recurring return hardware as well as sequentially recurring accident that is terminated upon a failure detection. So he will terminate, not take a break. No, basic means a fault tolerance because fault tolerance is about making machines more dependable. It is the importance of proper means by which to guard such dependable. Now, fault is associated a metric is about machining, making it more dependable. Now, in this section, we will examine some of this heuristic. Heuristic means maze and the application. A maze is a mathematical abstraction that expects some relevant fact set of the performance objects. In this course, I will tell you about so many mathematical derivations, equations, and the numerical problems in upcoming lectures, in upcoming video sessions. By its very nature, maze only captures some subset of the properties of an object. Its very nature make and can only capture some subset of the bodies from the objects. Now, the thing in the form of suitable is to keep this set on the downstream so that the behavior of interest to the users as capture and yet the no so large that it makes loses focus. Now, after that, first we discuss what is the additional mirror. The transition mirrors of the bundle of a single computer. These methods have been around for a long time and make many basic attributes of the systems. Two of these means reliability and availability, not the conventional definitions of reliability, thereby all over T is the probability as a function of the time that the system has been conducive in the time interval 0 to t. These measures is suitable for application in which even a momentary disruption can prove costly. One example is computers that controls physically processes such as an aircraft for which millions listen content to the relative. There are so many cases I will tell you in upcoming video sessions. Closely related to the reliability, the mean time failure rate and the WTF and the mean time between phase MTBF. No, the traditional mirrors comes. The area with detailed explanation. The first is the average time the system is under failures. As the second is the average time between two consecutive failures. Now the difference between the two is due to the time into the repair system following the first one. denoting the mean time to repair by MTTF. MTBF mean is equal to MTTF plus MTTR. I will tell you what is MTBF. MTF is mean time between failures. Is equal to mean mean time to failure. Mean time to failure plus mean time to repair. Availability denoted by A over time. Is the average function of time over the interval 0 that the system is up. These measures is appropriated for application in which continuous performance is not vital, but where it would be expensive to have the system for significant amount of time. An airline system needs to be highly available because downtime can put off customers and lose sales. However, an occasionally short duration fuel can be well tolerated. Now, the long-term availability denoted by A is defined as is equal to limited time into infinity A over time. A can be interpreted as the probability that the system will be up at some later point in the time and is running full and the system time to include a pair of faulty components. The long-term availability can be calculated for mean time to failure, mean time between failure, and mean time to return repairs. And there this formula. And this is the formula. This is formula, this formula, this formula, formula, this formula, this the formula is discussed in this lecture. Related measures point to availability by AP over bracket time. Quantitative of function over time. Now, it is possible for full reliability system to have high availability. Consider system that fails every hour on the average, but comes back off near second. Now, after such a system has a mean time between fail of just 1 hour and consider the low reliability over its availability side. A single T599 over T600 for this formula. Right. Long-term availability. After that, this definition solution, of course, that we have a state in which the system can be set to up and another in which is it is not. Now, after that, for simple component, this is a good assumption. For example, light bulb is it a good or poor? After that, why is it connected or as very connected? However, finding even simple systems such as assumption can be very limited. For example, Consider a processor that has one of its several hundreds of billions of gates done at logic value 0. In other words, the output of this logic is always 0, of regardless of the input. Now after that, suppose the rest of the processor is functioning and that this failed logic gate only affects the output of the processor. But about once in every 24,000 hours surface. Imagine, imagine, zero logic gate affects only one fail logic gate affects the output of the processor only once in every 25,000 hours of use. Can you imagine it? No, example, a particular cat in the device when being faulty means that in a long quotation if the device is within a certain subset of is telling about the calculation between DLT, digital logic design. Now, clearly the process is not fault free, but would want to find it as the down. Now, this is good. Now, it is the answer. The same remarks apply with even greater force to system that degrade. Guess what? By this means systems with various levels of functionality. Now, initially, with all of its components, operational, the system is at its highest level of functionality. As these components fail, the system decays from one level of functionality to the next. Behind a certain point, the system is unable to produce anything and use and fails completely. No, no, as with the previous example, the system has multiple upstates. It is said to fail many decades from full to partially functioning. Oh, when it fails to produce any useful output at all. Or when its functionality falls below a certain threshold. Threshold in Latin, what is the threshold? If the last what is the threshold and what is determined, we can therefore see that additional reliability and availability are very limited in what they can express. There is a previous extension to these measures. For example, we may consider the average computational capacity of a system with n processors. Says, so n processor. Let's see I denote the computation considered for system by I operation processor. This can be a simple linear function. Now you're starting out a linear function with numbers of Ci equal IC1 or a more complex function of I depending on the reliability, depending on the ability of the application to test I processor. Now, the average computational capacity of the system can be defined as summation n I sigma C1 Pi over time. This is the formula. Where Pi is the probability that exactly I process operational at time t. In contrast, the reliability of the system T will RT summation n I sigma Pi over t. No, where M is the minimum number of processors necessary for proper operation of this system. No, network layers. In addition to the general system layers previously discussed, there are also more specialized layers focusing on the network that connects processors together. Now, the simplest of this classical node and then connectivity, which defines the minimum number of nodes and lines. Especially that have to fail before the network becomes disconnected. It's talking about the internet networks, internet connection. Sure, sure. No, classical connectivity is a very basic needs of network reliability. Like reliability, it distinguish between only two networks. Network stays connected and disconnected. You have learned, you always listen this one, the connected, disconnected, connected. Now, now consider two networks shown. Now, this is the first week. E network is a classic. uh, This is the first network 1 and network 2. This is node A and node B of two networks. The pawn networks have the same classical nodes connectivity of 1. Now, I will use first network and was much more connected than N2. Look, network 1 is much connected to the network N2. Now, the probability that N2 splinters into small pieces is greater than that of N1. Now, to express this type of connectivity robustness, we can use additional mirrors. Yes. Two such mirrors are the average node pair distance and the network container, and the network diameter, the maximum node pair distance, both calculated the probability of node and the leak failure. Such network needs together with the additional layers listed above allows to gauge the dependability of various yes, the work system consists of computational nodes connected to a net of communication links. Now, the outline. The next chapter is titled Artificial fault tolerance. And this is the most established topic within fault-tolerant computer and many of the basic principles and techniques for it have been extended to other forms of fault tolerance. Techniques to evaluate the reliability and the availability of fault tolerance systems are introduced here, including the use of Markov models. Markov is the Russian scientist. Next, several versions of information redundancy occurs that limit the most widely used error detecting and correcting codes. codes, codes. Then other forms of information redundancy are discussed including storage redundancy less system. Data replication distributed system following the algorithm based for tolerance techniques that tolerate data in array computation using some error detecting and error correcting codes. Now, man, many computing systems nowadays consider multiple network processor data subject to interconnection link failure. So in addition to already discussed single node processor failure. Now, we therefore present this suitable fault-tolerant techniques for these networks analysis matters to determine which network topologies are more robust. Software managed textbooks are in practice another and consequently some software faster than some must. These can be as simple as acceptance tests to check the reasonableness often results before using the LS complex as running to more versions of the software sequential name pattern. Programmers also tend to have their stairs right after running for long periods of time and eventually crash. This suggestion can be avoided by a practically listed program process called rejuvenation. Unlike hardware faults, software faults are very hard to model. Still, a few such models have been developed and several of them are described. Hardware faults techniques can be quite costly to implement them in application which are complete and immediate masking of the effect of hardware results. Special process nature is not necessary checkpoints is an inexpensive alternative. For programs that run for a long time and for which re-execution upon failure might be too costly, the programmer state can be set once or periodically then execution. When a failure occurs, the system can roll back the program to the most recent checkpoint and resume its execution from that point. Various checkpointing techniques are presented and analyzed in the book. Instead of listing the use of any of the four balancing techniques described previously and presented, including tenders, starters, casingly, and the microprocessor from IBM and Intel. Two foreground topics that are repeating is practical components limit the defective tolerant VLSI means Verilog. The center followers in cryptographic tests are discussed. The increasing complexity of VLSI chip design has resulted in a situation in which manufacturing defects are unavoidable. If not, is that the limited this situation expected yet defection manufacturing the chips which are operational will be very low. These techniques to reduce the sensitivity of VLSI chips to defects have been developed, some of which are very similar to the hardware redundancy schemes. For cryptographic devices, the need for fault tolerance is twofold. Not only is it crucial that such tests example smart cards software in fault-free magnet in whatever environment they are used, but more important, they must test skill. Fault injection-based attacks on cryptography have become the simplest and the fastest way to extract a secret key from details. Thus, the incubation fault tolerance is a must in order to keep cryptographic devices secure. And the point of this evolution process of a fault-tolerant system determines that the system does indeed function at the advertised level of reliability. Often the design system is too complex to develop an ethical expansion of its reliability. If a product of the system is already been constructed and fault injection of experiment can be performed and certain dependability attributes merged. Certain dependability merged. If four hours is very common, a prototype does not yet exist, a statistical simulation must be used. Simulation programs for complex systems must be careful to sound produce accurate results. We discussed the principle that should be followed when preparing simulation programs. Ensure simulation results can be used for to infer system reliability. Now, further, several textbooks and reference books on the topic of fault tolerance have been published in the past. See, for example, 2, 4, 5, 9, 10, 30, 16. This is the reference 2, 4, 6, 8, 10. Then 13 to 60 journals have published several specials on the fault tolerance community. The major conference in the field of the conference on the Panther system networking. This is a successor to the fault-tolerant computing supremacy FTCs. The concept of computing began invisibly appeared in the context of previous that is coming that previous community living without being observers. The definition of basic terms and make up in most of the explanation and in several probability and statistics books. For example, reference number uh, exemplarity. Our definitions of fault and errors are slightly different from those used in some of the references. A generally used definition of an error is that the part of the system state that leads to system failures. Strictly interpreted, there is only applies to a system state that is within memory. Mm, well, we use the more encompassing definition of entity that can be constructed as manifestation of a fault. This wider interpretation allows polynomial combination circuits each as this to generate errors. One way of dependency that we do not describe in the text is to consider and we think everything the perspective of the application. This approach was taken to define the measures known as the performability. Now the application is to define accomplishments L1, L2, up to so on Ln. Each of these represents a level of quality of service delivered by the application. For example, Li may be defined as follows. The I system caches the time period. Now, the performance of the computer is this quality if it did not by definition, it would have nothing to do with the application. The approach taken by performance is to link performance of the computer to the accomplished that this enables. Performability is then a vector PL1, PL2, PLN. The PLN is the probability that the computer functions enough to permit the application to reach up to accomplished level. For one performance is 6 level. Now this is the references which I'll take make the lecture. Please like, comment, share, subscribe, and do not forget to press bell. If you have any questions, just add into comment section. Thank you, Allah Hafiz, and goodbye.